The Carnegie Institution for Science has different fields represented. We describe it as space, earth, and life. In each of those fields, people are fascinated with origins, with where did we come from in the biology realm, how did evolution work, and how did life begin on Earth, then where did the Earth come from, and then where did the universe come from. Those kinds of things have always been fascinating to people. It's a fresh topic because the science is moving forward, but so are the changes in the world today. So this program is a chance to bring together people. Some of them are scientists, some of them are artists, some of them are writers, to think together about origins of life, but also origins of what's out there in terms of earth science and astronomy in general.
Hi, everyone. It's good to be back here. So I'm a science journalist for the Washington Post, and I wanted to let you in on a little secret about science journalism. One of the first things my editor told me when I started my job, which is, it's never aliens. And this is important to remember because there will be times as a reporter where NASA has teased a press conference that they say is important to the search for life beyond Earth, or there's rumors about a journal article coming out, and everyone on the internet is like, it's going to be aliens, it's going to be aliens. It's not going to be aliens. Hopefully, it will be someday. Right? I want to write that headline. I want to write that story so badly because that will get me on the front page. But before we get going, I want to invoke something that I actually heard about the last session. One of the panelists, Jill Tarter, said that SETI, the search for extraterrestrial intelligence, is the archaeology of our own future. And what does that mean? Well, it takes time for light to travel across the universe. So any signals that reach us necessarily left their civilizations years ago. Probably, if they're 100 light years away, then that signal is a century old. So those messages are like time capsules from the past. But receiving such a message also implies something about our own future, because it says that it is possible for a civilization to reach the point at which it is capable of sending an interplanetary signal. And right now in our history, when the news is full of a lot of violence and the habitability of our planet is at question, it's worth thinking about, I think, are we going to become a civilization that could potentially send those kinds of signals? And what do we need to do to ensure that future? To make sure that one day I can write the headline, it's finally aliens.
I think most people think about intelligent life as being humans, but we all know that whales and porpoises have extreme intelligence. In fact, we know that even some invertebrates like octopus have extreme intelligence. They can predict the outcome of the World Cup. Personally, I think that life is probably very common in the universe or the multiverse. Does it mean that if all places life emerged and was microbial, for example, would it eventually evolve to intelligence? I think that that's less certain for me and probably a rarer phenomenon than I think life in general would be. I'm going to talk to you about how weird it is already and how much weirder can it get. I am interested in the 99% of the inhabitants of this planet, which is the microbial population. And I just want to share with you about things that I've discovered and other scientists have about how alien those organisms here on our planet are. And I'm going to talk about extremophiles. This I call the X-Files, and I'm happy to see that probably most people in the audience remember that show. It's dated now, and unfortunately. Extremophiles are defined, or extreme environments are defined as those that would not support normal biological life forms. And what that actually translates to, it's anthropocentric. And so it's from the point of view of the scientists that are actually studying these organisms. These are environments that we as scientists or humans would not enjoy living in and probably could not. But to them, it's completely normal. So I'm going to start out with sort of the est of the microbial world and begin with something known as thermophiles or hyperthermophiles. These are organisms that live at very high temperatures. In fact, the limit of the temperatures that they live at or that have been recorded is 121 degrees C. Now, the slides I'm showing you are going to show you environments where we find these or pictures of these organisms. So there's a hot spring in Yellowstone Park and a deep hydrothermal vent on the right side. And just to give you a perspective, I'm sure you know that water boils at 100 degrees C. Hot coffee is 85 degrees C, and you know how well it would go with your life if you dumped that on your body. You basically would not survive being dunked in a pot of coffee, much less be able to thrive and divide and reproduce. On the other side of that temperature scale are what we call psychrophiles. These are cold-loving organisms, and you find them in places like Antarctica or the high Arctic. They often live inside the interstitial spaces of ice. For perspective, we've measured growth down to -15, metabolism down to -20 at least, and survival down to -40, actually -80 degrees. And for perspective, we all know room temperature is about 25, 26 degrees C. Your freezer is about -20, and the coldest day in Buffalo is about -40. So most of us would not be able to exist for very long without proper clothing, in particular in Buffalo. So the acidophiles, these are organisms that thrive at high acid. These are hardy microbes that can thrive at a pH of 0. The normal pH scale where we find organisms is between 5 and 8. We ourselves like 7, 8 pH. But they're living at pHs that are lower than your Coca-Cola, which is at pH 3, vinegar, which is at pH 4, and battery acid, which is at pH 1. Now, on the other side of the scale, they're the alkaphiles, those that can persist at high pHs. These are in soda lakes and alkaline lakes in the Sierras. They can live at 12.8. And this is very similar to oven cleaner, which some of us may still remember when our parents used to use that to get all that grime and dirt off. All that organic material would bubble up and be destroyed from inside our ovens, or there are organisms that actually could live in that. Basically, everywhere we go on our planet, no matter how extreme it is, we seem to find organisms. And it makes me think that what has happened here on our own planet, that is the emergence of life, probably happened many other places. And one of the quotes that is really important to keep in mind, which is to consider that the Earth is the only populated world in infinite space, is as absurd as to assume that a field that's sown with millet, that there would only be one grain that would grow. So in my mind, it's not a matter of when we meet or if we meet life, but when we meet life. So thank you.
So before we move on to the next one, I wanted to ask you a question, Mary, which is that earlier today you said that you wrote to find microbes, yes. And that you actually think it might be potentially better, if we're searching for life elsewhere, there may be some benefits to finding bacteria or tiny little bugs first. Why do you say that? Well,
I like the idea of looking for microbes just because in our own Earth's history, it populated the Earth for many billions of years, as opposed to how long we've been on the Earth and how long we were able to send out messages or be heard by anyone that might be listening. So I like the odds for finding microbial life because I think if it's thriving on a planet, it may have been there for a much longer period of time. And so if we find a place that has microbes, it may also have intelligent life, or it might be on a trajectory to eventually evolve intelligent life. And so for me, it's a really great start for the search.
I think we've got a question over here.
Hello. So I have a question for Mary. I was wondering, how do organisms like extremophiles and xerophiles help us understand foreign intelligent life and how they function?
So I mentioned before that the importance to me of understanding extremophiles really speaks to the possibility of life. And it's not just simply that we find them in these weird places, but they took a set of tools that a cell has and figured out how to adapt it and adjust it to adapt or to modify actually their environment so that they could actually persist there. And I think To me, microbes are the original, they're the original explorers. They went into new environments. They figured out how to go from the nice, maybe warm little pond in which they arose, as is one of the ideas where life emerged, and then decided to go into hot acid pool. And they went for it because there were resources, and even despite the threats, they figured out how to colonize it. And so I think, if we think about certainly exploration and possibly adaptations that can allow us to explore and potentially colonize, we can look to the microbes, which came before us and were successful for several billion years.
Oh, I think fiction has done a great deal to prepare us for a first contact, should it ever come. So I don't think that we're going to be surprised that much, or it's going to be that much of a shock. I do think that art has prepared us, the science fiction movies, the sort of artwork that I and my colleagues do. I think the public is well prepared to find it. Scientists gather data and try to interpret the universe. Astronomical artists try to interpret the scientists. I recently came across an interesting legal principle called the scintilla evidence rule. It states that if there is so much as a mere gleam, glimmer, spark, the least particle, or the smallest trace of evidence supporting an inference, then the issue must be submitted to a jury. Somehow this reminded me of astrobiology. It's a field in which its practitioners are so ardently seeking its subject that sometimes they and we who try to interpret them get carried away. A case in point is Percival Lowell. He was a Boston Brahmin in the 19th century, very accomplished man, businessman, wrote very scholarly histories. In 1894, he established an observatory in Flagstaff, Arizona, to study Mars. Now, there's a saying at NASA that Mars is hard. It's hard to reach, and it's also hard to observe. Earth does a flyby every 2 years or so, and that's when we get a close look. But even then, when Mars is closest, it looks no bigger than a penny seen across the length of a football field. And the magnification required to show detail on its surface also magnifies the trembling distortions caused by Earth's atmosphere. So Percival Lowell saw something like this simulation. He sketched it from night to night, very assiduously, and he drew lines, hundreds of lines. Anybody looking at a map that Lowell produced would conclude that the lines were a definite sign of intelligence. Lowell thought that the lines were evidence of a vast network of canals that inhabitants of Mars had built to transport water from the polar ice caps to the equator. This is my interpretation of what a Lowellian canal might have looked like. The canals converged at oases, where the Martians maintained farms against the encroaching desert. His ideas quickly got into the culture, so much so that in 1911, when he announced that the Martians had opened a brand new canal, 1,000 miles long, 20 miles wide, the New York Times, a former newspaper, reported it quite soberly. Not everybody was convinced that the Martians would be wise and noble. H.G. Wells thought that they might be very practical and invade Earth eventually. His Martians were cool and unsympathetic and not very pretty. In 1938, Orson Welles, no relation, had Martians invade New Jersey during a radio broadcast, a drama. People tuning in the middle of the broadcast thought that it was a news report. That's how firmly established the idea of life on Mars was by then. By 1960, when we were getting ready to send probes to Mars, most astronomers knew or believed that the canals were a fantasy. The air was just too thin. It didn't really, and nobody else could see the canals, very few people. Nevertheless, the first maps used to plan the target locations for photography still included ghostly remnants of the canals. In 1964, Mariner 4, flew past Mars. The pictures it sent back were very disappointing. There was no trace of canals. It showed a barren, cratered, very bleak surface. And even though nobody really expected to find canals, we were all disappointed back then. So it turned out Mars was a very inhospitable place. So why are we still looking for life on Mars? We're actually obsessed with it. It turns out that the initial probes happened to fly over particularly bleak locations, and there were actually evidence of ancient rivers and lakes and even an ocean. The Curiosity rover is currently roaming around an ancient lake bed in Gale Crater. And some scientists think that maybe it's found evidence. It's very speculative, but these rock formations look a lot like fossils called stromatolites. They're formed by algal mats, layers, biofilms that build up. Some of the most ancient fossils on Earth are stromatolites. There is a red dwarf star called TRAPPIST-1, about 40 light years from Earth, and it has 7 planets. All the planets are roughly the size of Earth. A couple of them live in the habitable zone where the temperature is just right for liquid water to persist on the surface. So here's my interpretation of a planet of a red dwarf star. Such a planet would likely be tidally locked, one side always facing its sun. A subsurface ocean might steam like a tea kettle. It would have a very different climate than anything we've seen on Earth. Near the terminator, the line between day and night, the sun would be poised perpetually on the horizon. It would never move. It's always the same time of day on a red dwarf planet. So I postulated that in shadowed zones, in zones of shadow, perpetual shadow, there'd be die-offs. And so forests might tend to grow in waves toward the horizon. I call this painting the marching forest. So from dots crossing in front of a star, I've conjured up not only a climate, but an ecosystem. In order to find out more, we're going to have to build better instruments. This was the case with Mars. We'll have to gather many more scintillas of evidence to submit to the jury before we get there. Thank you.
So Don, you talked about sort of connecting the dots between what scientists know and what we can imagine, trying to kind of color in the lines of these worlds. What are the benefits and the perils to trying to sort of connect these dots using our imaginations? Are there any hazards in imagining things that we don't yet have data for?
The hazard is that we will imagine something that's not true, and that will deflect our search for the real truth. Once we get an idea in our head, as Lowell did, it's very hard to move on. You have to, there's actually resistance to interpreting new data as it comes in if it contradicts what you already believe.
Is there a benefit?
A benefit? It inspires people to look further, and by putting ideas out there, it gives you something to challenge. It gives scientists something to challenge. They'll look at a theory and say, oh, that's nonsense, and they go about trying to prove that it is nonsense. That's how it works.
For me, the definition of intelligence in this context is one that can communicate with us and ones that we can learn from. Having a conversation with a being from another world, having that initial contact and trying to understand cultural and biological issues and similarities and differences, that is the most exciting part, I think, of making contact with another species. This session is more about how this affects society, like how the discovery of life elsewhere would affect us. And I can't tell you that, because it's not up to me. It's up to you. So in this tree of life that we see depicted here, we are only one tiny, small part of that. The rest of this is usually filled in with our understanding of DNA and extracting DNA and doing DNA amplifications. But that entire tree, this illustration from a paper that's supporting Gil Levin's premise that the Viking landers actually had a positive detection of life on Mars, made me think about it. All of that tree fits into a new category of terrestria. Whilst I don't think that this is correct scientifically or defensible robustly scientifically, it does illustrate something that's extremely important as part of this concept, is that this is another tree of life. Or is it? Right? Was it spawned from Earth? Are we spawned from it? Is it a second genesis? This actually illustrates that really very interestingly for me. We've had other controversies about life on Mars. The 1996 announcement by Dave McKay of NASA that we'd found life in the Martian meteorite ALH 84001, which is actually the start of my journey down the road of origins and Mars life detection. I think this got to the point where even Bill Clinton announced this at the Rose Garden. This is how much it affected the kind of scientific and political landscape of the time. But what that showed us is a couple of things. Number one, Dave was right to make that premise. He may not have been right ultimately, but we still can't say he was wrong. But the burden of evidence that Dave presented has been chipped away at by the scientific community. The interesting thing about it is that on this graph, this illustrates that the only way you're going to get a successful life detection is by community acceptance of the results. If we can't nullify those results with other explanations. And in the time since we have been, and it's been part of my work, to critically evaluate those initial observations and put them into context. In popular culture, we can dream and think about organisms and weird life elsewhere, but a lot of our thoughts on this, and this was in our discussions today, illustrated is our imagination actually good enough to imagine what alien life would be like, right? On top left, you have a blobfish. That is actually a fish. It lives at high pressure. It's just when you bring it up, it collapses. But I was struck by the similarity towards Jabba the Hutt from Star Wars, right? The other image at the top right, as I'm looking at it, top left as you're looking at it, that's a louse that lives on a fish tongue. What you're seeing there is a fish, and the louse is actually taken over its tongue. It feeds off the blood of the fish, right? And what you see below it is my favorite alien, I'm afraid, which is the alien from Aliens. This was a headline from the Daily Mail. It's not one of your headlines, I'm afraid. Half of humans believe in aliens and want to make contact, despite warnings it could wipe out mankind. What we have here is a love-hate relationship, right, as a species with aliens, right? We want to believe that they're there, but we're really quite scared of them. We don't want them to be nasty to us. So we have this hope and a fear. And I wondered a lot about that, as if that hope that we're not alone and that fear that we are, or that fear that we're not alone. And those are very, very human reactions. So what I wanted to get tonight with this talk, the purpose is what do you feel about this? Not what you think. Thinking is only part of being human. Feeling is the other part. What do you feel about this? Because personally, I think the search for life elsewhere is in fact a search for ourselves. And I invite you to think about that. Thank you.
So Steely, speaking of feelings, say you found unequivocal evidence of fossil life on Mars. How would you feel?
Probably tired. No, I've obviously been made up, but as a scientist, you tend to suspend emotion. So asking from a scientific standpoint, it's obviously like, okay, you know, how far is it distributed? When was it made? When did it die out? What was it made of? What are the components of it? How are we going to get there and look at it? Is Craig Venter going to patent it? You know, all of these things immediately go through my head, but how would I feel? I would feel relieved. I honestly say relieved, I think.
Why relieved?
Because I have followed this tenet that life is a universal prerogative, and that we are just one manifestation of that, and that the microbes that lived on Earth 3.6 billion up were a natural consequence of natural processes that led to us in the end. And so I would be relieved that that was a second illustration of that process, because I think it's reassuring. Because if it happened somewhere else, just one other place, it happened everywhere. Not just here.
Right, so I think it's time for our technologically advanced portion of the evening. It's author David Bren speaking to us from California.
All right, so I'm going to move on to the first slide here. What we're facing in the great context of life in the universe is what's called the Great Silence, or the Fermi Paradox. The Drake equation is my friend Frank Drake. I saw him in DC a couple of weeks ago. Is a way that we organize our thoughts about how many alien life forms might be out there and detectable. I'm sure in this audience, almost everybody has seen it, the number of stars times the fraction that have planets. We now know, 20 years ago, we knew of no planets outside our solar system. Now we know of thousands. So that factor is being reduced, is being brought up to 1, rather. The fraction of those planets that develop life, the fraction of those planets that have life that develop intelligence, the fraction of those that develop a communication, F sub C capability, and the lifespan of those worlds. Now, I told Frank, this doesn't predict a darn thing. It doesn't predict how likely it is that we've seen anybody, if they, and we'll get around to that. I have a slide that I've been showing to a lot of government agencies. I just showed it at several agencies just 2 weeks ago in DC. And it goes through the different ways that civilizations have collapsed in the past. Repetition of past failure modes, natural calamities, ecological suicide, enemies in war, being outcompeted, societal meltdown, and the feudal attractor state. And then I've also been talking about new calamities, AI, augmentation, the Anthropocene, bio, nano, cyber, and the opposite of this, which is renunciation. What if we get so scared that we renounce the future? There have been a lot of sci-fi stories about that, and there are large sections of the world, including ruling classes and frightened fellow citizens, who want this, who want to step back from our pell-mell race into the future. And the two bookends concepts that we have to bear in mind are the singularity, and then the other one is the one that we're talking about, the Fermi Paradox. Every time we come up with some new thing in our civilization, we have to ask, is this it? Is this the thing that's going to make us one of those races that have a short lifespan? And is this the thing that filter that explains our failure to discover others in the universe and their failure to discover us, because we'll kill ourselves off? On that gloomy note, I'm going to show you something cool, and that is the number of expeditions we've sent out to various planets, to the sun, to Mercury, to Venus, and the three places that we're arguing over whether to go to where we should go next with human spaceflight are the moon, Mars, and asteroids. And there's a fourth category, which is the roofed worlds, the ice-covered worlds. We used to know about Europa having an ice roof over a liquid ocean, then Enceladus orbiting Saturn, and then Titan with wax and gasoline seas at the top, but possibly a liquid water ocean down below. Now we believe we know of a dozen of these worlds in our solar system alone. I mentioned the Goldilocks zone. Raise your hand in the audience if you've heard of the Goldilocks zone. And now raise your hand if you were too shy or lazy to raise your hand. Too hot if you're too close to your star, too cold if you're too far, just right in the middle. But what a lot of people don't realize is something very special about the Earth. We skate the inner edge of our continuously habitable zone. It extends past Mars. So why does Mars appear to be dead? Why is it frozen out? Because it didn't get the two things you need for a Gaia effect. One is a liquid ocean, and the other is volcanism, plate tectonics, to restock the atmosphere with CO2, and then oceans and weathering of continents to take the CO2 out. And what a lot of scientists believe now is you strike a Gaia balance. And if Mars had been the size of Venus or Earth, it would have struck a Gaia balance to have oceans. We could have gone down and surfed. But wearing respirators, because its Gaia balance would have had a dense CO2 atmosphere. We're at the other end. We skate the inner edge of our Goldilocks zone. And as a result, our Gaia balance has to have almost no CO2 for us to lose enough heat. And that means that we need just enough CO2 in our atmosphere for plants to live, and no more. And this helps us answer the climate skeptics who say, how could it just mere humans alter the climate of the Earth? Well, we can't afford any more CO2. So there's Drake's equation again, and here are some of the things, each of which would be worth a week-long conference, let alone an hour. Advanced aliens. Why do we not see them? Why do we not see the great works they would make? Because we intend to make great works that would be visible from light years away. Are they rare? Are they paranoid? As we can see, if you click again, Liu Cixin's famous book, The Dark Forest, talks about a galaxy filled with paranoid advanced aliens. Or are they protective? Are they hiding so that we can enjoy our infancy? Equals. What if we meet equals? Well, in Star Trek, we meet a lot of equals at exactly our same level of technology. That's a temporal coincidence. Will we compete with them as in Star Trek? Will we merge with them and mate with them as in Star Trek? Who the heck knows? Near equals. What if they're almost at our level, a little above dolphins, a little above apes? And they might need a leg up in order to become a star-faring species. What is the moral thing to do? To not meddle or to leave them stuck below a glass ceiling? These are very, very interesting questions. And if you click again, you can see the Strugatsky brothers' novel, Hard to Be a God. And of course, my novels deal with this extensively. And then there's ecosystems. What if nobody's near our level? Does that mean we have a right to colonize, despite the fact that colonization cannot help but make at least some extinctions, no matter how careful we are? Or should we alter ourselves to fit into their ecology? Should any discovery of microbes make a planet off limits? Mars for the Martians, if we discover one microbe. Vast implications for human survival, ethics, even theology. Without any doubt, our wisdom has been advancing spectacularly, even since Kubrick's 2001: A Space Odyssey. The question is it happening fast enough? And so we've moved to just about the last slide, which all leads to the question, maybe we are the first. Maybe we'll be the first to overcome all of these filters, all of these obstacles. And discussions like this are part of what we would do if we intended to be the first. If we got out there, we might find a galaxy in which there's been a lot of tragedy. And maybe we can be the ones to get out there and help others. What a duty we might have. And that is a duty that we might have to survive and thrive. Thanks.
I used to have a bumper sticker for my car that said, "Beam me up, Scotty, there's no intelligent life here." And that got me thinking, who are we to say what is and what is not intelligent? But even more importantly than that, who are we to place a value on life on the basis of a single parameter, such as intelligence? We've addressed a wide array of topics, but they actually are dots that can be connected. We began with some discussion about extremophile life on Earth. And you might wonder why we explore extremophile life on Earth. And in part, it's to help understand the limits of its existence so that we might imagine what sorts of environments it might inhabit on other worlds if we are to go there and explore. Our perspective when we explore the Earth has always been one where we're looking at opportunities and threats. And if we ask ourselves how we would approach a completely alien species, probably we would approach it either as an opportunity or a threat. And which it is would depend upon our perspective of the moment. So we think of life and the search for life in terms of what we know about the evolution of life on Earth, which is not a whole lot. Most of the species that have ever existed are not fossilized. And Earth is a dynamic planet resurfacing itself and subducting the evidence of past environments. So our deep past is obscure. We can also think of life in terms of its complexity. We say simple life, and we refer to microbes. And we look at large biomass aerobes, such as ourselves, and we say this is complex life. I ask you to turn your attention to the life before you on the screen. This is a Prosaurolophus. I spent a little bit of time in Dinosaur Provincial Park in Alberta, and there was nowhere I could walk where I wasn't about to step on a dinosaur bone. What you see in the image, sort of in the center and up a little bit to the right, is a piece of a pelvic assembly of this Prosaurolophus. This particular piece of skeleton hadn't been found before, but we could have walked in another direction and found some other dinosaur. The point I want to make to you is, that's complex life. Where is it? It's gone. Life can be simple, life can be complex, but we can't really expect to judge its value, its utility to us, and whether it's simple or complex. So to address the question of whether we would prefer to find intelligent life or microbial life kind of doesn't matter, because what really matters is where you are in time. Is that life on its way to becoming this thing, to becoming more complex, or is it on its way out? It's hard to know that because we are at a moment in time. The entire universe is dynamic. So the possibility that we could renounce the future is in fact impossible, because with everything in motion, everything is in relationship with everything else. So where you were in relationship to other life, to other environments, even a second ago, is somewhere else now. So while we can't exactly renounce the future because it will inexorably proceed with or without us, we can close our eyes and say, I don't want to look. But that won't change the fact that it's coming. So can we be intentional about looking for other life? Yes, of course we can. This is Llewellyn Glacier up in the Northwest Territory of Canada. And what you see that looks like dirt there is all snow algae. And we went there at a time when there were some melts, and we were being very careful where we walked so that we wouldn't step on new blooms that we wanted to examine. But scientists don't always take such care when we're exploring extreme environments, and those environments don't always take such good care of us. We have been exploring forever because exploration is a thing that all organisms do. It's part of the biological imperative to look for opportunities and threats. The universe is huge. It's amazing. It's full of opportunities and threats. Do I think that there's life out there? Yes, I do. Do I think we'll find it? Don't know. But I don't think we can help ourselves from looking It's what we do. And whether we find it here, whether we find it there, I kind of don't care. I'd love to be the one that calls up Sarah and says, it's the aliens. Thank you.
You guys both talked about in Earth's history, there are stories of past encounters between societies, between biomes, and they often don't end well. And given that context, do you guys have sort of a philosophy or guiding principles for how we should go about potentially contacting life elsewhere?
David, you want to take this one first?
Just simply because you spoke first, I was going to offer to you, well, you know, the difference between microbial and advanced technological civilization is who has the initiative. I've been involved in the search for extraterrestrial intelligence for about 30 years, and in the last 10 years, at least 24 of the people in the field have resigned from SETI commissions in protest over what's called METI, and that's called messaging to extraterrestrial intelligence. It's not that we are against it in principle, but this is the sort of thing that it's arrogant to do without talking it over with people who have reasonable concerns. To be honest, if you look at the history of both biome contact and societal contact on Earth, I'd rather be the one who detects the other first. And let's understand that the METI people, many of them want to call out to aliens because they think that it's our only chance. They think that rescue from above, casting messages skyward to powerful beings who might intervene on our behalf. Well, we know we've been doing that for 6,000 years in every single human civilization. It's called prayer.
So while I've been an astrobiologist for 20 years, I've only been a priest for 10 months. But something profound affected my approach to astrobiology when I was in seminary, and that was a course taught by a post-colonial theologian. This is a woman who grew up in a post-colonial society in Hong Kong. And what I learned was the importance of dialogue and the absolute devastation that colonial exploration has wrought on societies since its inception. And one of my concerns as an astrobiologist has been, since I changed my worldview in that regard, has been how can we more gently explore so that we can use a process of dialogue to do just as David says, listen and understand as much as we speak. And I think that is in part what we do as scientists when we digest data. But if you look at the history of our absolute abnegation of all personal responsibility for the mistakes that we choose to make as well as those that we unintentionally make, it's about time to be intentional about making the choice of how to explore.
I'm very curious about the theological impact of finding alien life in another planet. In other words, how will it affect all the various religions in the world? We all assume that our Earth will all respond in a uniform way, but there will be so many different responses, a range of responses. Can you kind of react on that?
Sure. I get to use both sides of my brain. So this is something that people argue about. There's a school of thought that says it's disrespectful to God to even posit that there's life on other planets. So I'm not going to speak for all theologians. I'm going to speak for my own self and say, that's ridiculous. Because if we define a God that has created the entire universe that must mean that the entire opus of creation resides in that God. So why would we want to limit what is created to what we can see? It seems really arrogant. But I do think that your question gets at something slightly different, which is how will it change our theological reflection based upon the extant religions and possibly what may evolve from that? As I pointed out before, we live in a dynamic universe. Our thoughts are dynamic. And while it might seem like they stagnate from time to time, theological reflection is something that happens all of the time. So will there be new reflections on this? I sure hope so. I hope that every time we open either a trashy magazine or one of the holy scriptures of any of the religions, we'll try equally hard to get a theological reflection. Because as we try to understand greater meaning for our context, we can only go further and seek even greater meaning. And I think that can only be good.
This is a question for all of you guys. It's something that came up today in our discussion is why are we so obsessed? We spent a lot of money and put a lot of resources and brilliant minds into this quest. And, you know, why are we doing it and is it worth it?
It's a question that I brought up at our conference, and it's one that I've never come to a really good answer, but I suspect we're a little bit lonely. We have really nobody else on this planet to talk to, just our own species. We have just one point of view. I mean, various varieties of points of view. But we only see the universe one way. And I think if we contacted somebody else who has different ways of perceiving and interpreting, we'd feel that we were part of something maybe bigger than this little planet.
Some more questions? Excellent.
I was thinking about the whole idea of alien, and we treat each other country to country as if we are aliens and from another planet, and we don't relate here as well as we could. So I'm wondering how we can even think about how we will relate to aliens when we find them on another planet, when we really haven't learned how to do that here. So that was just something that came out from tonight's discussion. We will probably talk about it in the car on the way home.
Do you think the opposite is also true, that having discovering aliens will help that problem as far as our species is concerned? That will help us open that dialogue and feel more together as a species, when we know that there is another species out there that we must communicate with or live alongside. I'm curious to know your thoughts.
I feel it's always the we and the them, and if we have to fight together against them, will that unite us all? But I don't think that the we here on Earth will come together in a way before that 100 years and we blow each other up, for us to come to that point where we can relate well enough to each other to come together.
If I could offer something that might conceivably help cheer up this young lady. Look in a mirror. You have many reasons to look in a mirror, but one of them is the fact that you are not alone. The very value system that you just expressed is one that is incessantly in our media, well, not the crazy media that's driving us crazy right now, but I mean in movies and in our culture and in music and in song. If you look throughout human history, this notion of otherness, this notion of judging ourselves Name one other culture that ever taught its own children, by all means, grow up and criticize your own tribal elders. Your tendency towards self-criticism that you just expressed, criticism of your own culture, its inability to adapt. This is the very thing that we need. You're an immune response against the problem that you just described. You are an example of the millions, the tens of millions of people in this civilization who do want to reach out, look for the next problem. So I don't know if I've convinced you to cheer up a little bit, but I will say this. A little optimism can go a long way towards girding you with the confidence to feel you can solve the problems that worry you.
All the way in back?
Yeah, I think he needs a...
What makes one think that other life forms, extraterrestrial ones, either sentient or not, will have an interest in dialogue? and you know, may be just like us.
That was funny. I was going to say, we had a discussion where, I'm going to paraphrase, that maybe one of the reasons we haven't heard anything is that that other species have been here and found us boring and moved on. So.
Yeah, I think that dialogue has a role in conflict resolution. And when we think about these scenarios, the paranoia scenarios, where aliens are perceived to be a threat, dialogue is a solution to uncovering whether or not the threat is real or perceived. And I think the point of saying that dialogue is a key to post-colonial approach to exploration is really to say, if we don't go in with the assumption that whatever we discover is ours to exploit, we'll have a more gentle footprint on whatever it is we do find. Your point is well taken. There may be no interest in dialogue with us. I think many of us have seen the old Twilight Zone episode, To Serve Man, which turns out to be a cookbook. And I think that we can't predict. But if we go in assuming that whoever we find is ours to exploit, then it will end badly.
If faith is a belief in the unseen, Dr. Steele, you've expressed that kind of belief in ultimately expecting extraterrestrial life, and you have, Reverend Conrad, have, I guess by your own career choice, have expressed a faith, at least a faith in grace, so something larger. Or is your faith the same?
Is our faith the same?
I don't think so. I think it's the difference between the empirical and belief, isn't it? As a scientist, I can't have beliefs. I have to have measurements.
Oh.
And
I don't buy that one at all.
Yeah, but it's true. But as a human being,
it's not true.
As a human being, we have spirituality.
How many times have you done the same experiment because you have faith that you will get a result? And everyone who has slogged their way through a PhD has faith because there are days when you just don't want to wake up.
I suppose that's true. I mean, but I would categorize that as sheer bloody mindedness. It's just being stubborn. What my personal feelings are not as important as what your personal feelings are. So I'm going to put the question back to you and ask you, what do you feel?
That seems like a good point to end on because we're running out of time. So thank you guys so much. Dr. David Tatel, who's been an integral part of this whole series, is going to give some closing remarks.
So when Matt, where are you? There we are, okay. So when Matt asked Edie and me to help plan his new Science and Society program, we were deeply intrigued with his plan to use the new program to demonstrate to government officials and to the public how the scientific process works. Not to give them answers, but to show how scientists think. That's what Carnegie has tried to do in these 4 Origins programs, to show how scientists think about what may be the 2 most important unanswered questions we as humans face. Where did we come from? And are we alone? I'm always asked, what are the takeaways from tonight's session? What's the takeaway? I turn to the words of one of humanity's great scientists, Dr. Stephen Hawking. Listen to them carefully, please, because I found them yesterday before I heard tonight's discussion. And I think they're just a perfect summary of what we heard. Quote, "The search for extraterrestrial life is a call to thought. 3 years ago," he continued, "Voyager 1 broke the sun's embrace and entered interstellar space. With cooperation and commitment, the present century will be the time when we graduate to the galactic scale, seek other forms of life, and so know more deeply who we are." Thank you.